So today I'm going to be discussing kind of automation around vulnerabilities and different types of vulnerabilities and kind of how we can think about vulnerabilities at a larger scale. So quick who am I? My name is Tierny Cyren. My pronouns are he and him. I'm a developer advocate at Microsoft, so I work under Azure. I just recently changed to open source engineering, so still a DevRel under doing full-time open source. This means working on Node and other JavaScript ecosystem projects to kind of just be there and help. Yeah, I'm collaborator on Node.js. That's kind of a deceptive term because there's a lot of things in Node. I think we're up to 160 repos that are not archived. I'm a collaborator on about 10 to 20 of them. So yeah, help out with Node a lot. It's how I got here, and I love it. Okay, so let's talk about attacks. Specifically, how a Node.js application can be attacked. So quick show of hands. Who thinks they cannot be attacked by a vulnerability today? Oh, I saw your hand. Okay, cool. How many different ways do y'all think you can be attacked? Okay. So we're gonna get into 4 different kinds of ways you could be attacked today in terms of Node.js and your deployments. So one is supply chain attacks, right? How many of you have heard of LeftPad? Okay. The number the number of hands goes down every year, which is great because it means there's more people. But yeah, so LeftPad is one kind of supply chain attack. How many of you know of Pinky Promise? Okay, 2 people. Yeah. So Pinky Promise was basically LeftPad, but it was from the Npm registry unintentionally rather than maliciously via a module maintainer. Well, relatively maliciously. Also, you know, including or outside of your dependencies going away, there's actually specific attacks, targeted attacks on the platforms you use to get your code. So recently there was a Docker Hub attack, or an attack on Docker Hub that compromised 19,000 accounts. That also, certain paths could lead to that compromising GitHub accounts, which then compromises your entire stack. So whether it's employees in your team who have published a Docker image that were or a Docker image that their account was hacked, or their account can be compromised and they're a maintainer of a massive module in the JavaScript ecosystem that's on GitHub, there's problems. So this is a very scary kind of attack because your code just disappears or is not addressed as it should. Okay, so social engineering vulnerabilities. So this is something like Event Stream. This is a very amazing attack. I was concerned about this for like a year and a half before it happened. I had warned people and it happened. Basically, taking the human element of maintainership and using that against someone to get credentials of an important module or any kind of Docker image or anything kind of that you rely on. Dependency vulnerability. So this is the one that most people are aware of. This code was not well written or maliciously written to specifically so it could attack you and your stack. There are several hundred. Some databases range up to 1,000 vulnerabilities for JavaScript, and in our ecosystem, this is the one we kind of talk about most, and the one we're kind of most aware of. Then there's runtime vulnerabilities. So these are vulnerabilities in the runtime itself. We, as a project, Node ships vulnerability updates. Often we have a disclosure policy of, I think, a week. So a week before security update is about to go out, we will tell you, and we write a blog post. This is a blog post from February of a security patch that we were releasing. So far, since Node.js and IO.js merged, there have been 26 of these releases. That's from 4.0 to 12.5 as of today. So yeah, that's like not a massive amount considering how often we release Node, but it's also a non-trivial amount because I'm guessing most organizations haven't updated 26 times. Like that's not a thing most people do. So let's talk about how we can protect from these. Usually people address these problems, address vulnerabilities with a single tool. They pick a tool, that's the one they use, and they're done. There's a lot of apps in GitHub that you can kind of use to automatically surface vulnerabilities. They pick that, and they're good. That's not really how we should be thinking about this. We need to be thinking of it as a more holistic approach. We need to be addressing the entire stack and every kind of vulnerability. So we kind of need a set of utilities that we can really rely on and address issues when they come up. So these are the kind of coverage. This is the kind of coverage that we need: supply chain coverage, social engineering, vulnerability coverage, and runtime coverage. This is the kind of core set of how you can be attacked in Node, covering the vast majority of different methods. So let's talk about supply chain. Supply chain is an interesting one. The answer really is you need to be caching. You need to cache the modules that are important to you and your team. So many people don't just reach out to the public registry. I know some of the biggest users of Node.js and JavaScript in the world don't think they're reaching out to the registry. They think they're caching, but they're actually not. And even most teams, whether it's a startup or a massive enterprise company, often don't do this. Enterprises are much more likely to do this because they have tooling in place that already kind of interfaces with this. But most people I've talked to, most teams, most orgs, do not do this in any way. So why do you need to cache? You need to cache because the modules you rely on are not guaranteed to be where they are right now. If you cache the modules, so say I do npm install React. If I cache that install, all of those dependencies I own now. And I don't mean I own them as a maintainer or as an open source developer. I mean I have the literal tarballs that I need to download from the npm registry to make my application work. That is incredibly important because if npm goes down, you still have your code. If npm goes down and you don't cache, you're in trouble. Same goes for Docker Hub and Docker images. Like any kind of artifact that you're getting, you need to be retaining for some amount of time until you either invalidate it or it becomes totally irrelevant to you, which often in JavaScript isn't often. Cool. So all of these vulnerabilities, Pinky Promise, LeftPad, and Docker Hub, the Docker Hub breach, could have been resolved by caching. Nobody would have been affected. In Docker Hub is a unique case. You could have locked down your kind of external approach and not pulled modules from the registry, but or not pulled images from the registry. But all of these could have been solved in some way by caching. So please set up a cache. So how do you actually set up a cache, right? There's many answers at this point. This is a relatively solved space. In terms of the tools that exist, Verdaccio is a really good open source tool. It's specifically built in Node. It's a fork of, I'm trying not to say the incorrect one because I'm trying not to say Sonatype Nexus. So it's a fork of Sinopia, which was an older one. They've modernized it and worked on it a lot. They're releasing very actively, so I highly recommend it. Npm is a corporate version of the npm registry, so they will actually go spin up a Kubernetes cluster with the same registry infrastructure and do a lot of the cloning for you of any of the modules you're using, and also allow yourself to kind of pull from that instead of the public registry. It's relatively seamless. GitHub Package Registry is an interesting one. I really like GitHub Package Registry, and I hope to see this as a more official feature in the future. Right now, you could absolutely set it up as a module cache. It takes some work on your end, but it makes sense if you already use GitHub Enterprise or any of the kind of paid GitHub plans for your org. JFrog Artifactory and Sonatype Nexus are both very enterprisey products. Many larger orgs already have these, and so it makes sense to use them. If you have this, JFrog has a relatively low barrier to entry around just turning a feature on and you're good to go. I'm not super familiar with Sonatype Nexus, but they're both good tools if you already have them. So We've addressed supply chain coverage. Let's move on to social engineering. So here's a definition of open source social engineering. This is a tweaked version of the actual definition of social engineering as it applies to InfoSec, because this is a concept that we've not really talked about a lot. But at this point, with open source being as massive as it is, it's a really important thing for us to have a discussion about. We are very, very, very liberal in terms of how we give out access and credentials, and I don't think we should change that. That has been vital to the growth of open source and to kind of us as an ecosystem, both in JavaScript and in technology. And this is something that we need to at least be aware of and be thinking about. So this one is a bit hairy. This one is not very easy to address because there's a human element, right? And honestly, there's no simple answer. When there's a human element involved, the human is dynamic, and you can't really automate around a human. If someone's trying to attack you, they'll just attack around your automation. There's no direct plan of, I'm going to use this tool, set up this thing, and it will just automate away all these attacks, because we will just devise a plan of attack around that tool and leverage that tool's weaknesses to address your systems, basically. So this is really a bridge you need to cross when you come to it. I highly recommend setting up some kind of we'll get to this in a sec. So I highly recommend setting up some kind of incident response plan, right? Incident response is something that your SRE and DevOps team should be handling, or your ops team should be handling, making sure that you are ready to act when there is a time that you need to address some kind of social engineering attack. Specifically, event stream is a very good example of this. Getting that out and flushing that from your dependency tree and from all of your systems is incredibly, incredibly important, and you can't automate that. So setting up an incident response plan, using playbooks, which are a kind of DevOps-y term, basically defining every single path of how you can respond to this, and then kind of being able to act on that playbook and follow that playbook by the book when it comes time. And then also setting up incident commanders, I believe is the term, ICs. So this is individual contributors, but this is more along the lines of someone who owns this event. So this person doesn't need to be the most talented or most, the best engineer in the room or the most experienced with your systems or anything like that. They just need to be the one that can go through and follow every single step and make sure that they're coordinating the entire process and helping to kind of find resolution and eventually write up like an incident report. So taking those steps, here they are. Taking these steps can really help you kind of address human attacks like social engineering attacks when it comes time to that. I imagine that these are going to be happening more and more as kind of event stream saturates public discussion. It's very often discussed in JavaScript and Node, at least in my experience. And it's something that we need to be aware of and kind of addressing as we move on. Okay, so that's social engineering coverage covered as much as we can. So code coverage. We're not talking about this, right? We're not talking about Jest. Not at all. We're talking about this, your dependency tree, specifically node modules. We're talking about these things that before we just thought were innocuous, but now we realize, or somewhere someone realizes that they're not. They're actually dangerous, either intentionally or not. Luckily for this one, there is a simple answer. That answer is kind of automating your dependencies, specifically automating updating them. This solves multiple problems. There are tools that will automate actually letting you know when there's a vulnerability and maybe PRing that. I prefer to go down this route of explicitly automatically updating your JavaScript dependencies because it allows you to also build in rapid response to your kind of JavaScript modules and your applications evolving at the speed of JavaScript. So one tool that I really, really like around this is actually Greenkeeper. So Greenkeeper is a GitHub app. They also work with Bitbucket and a bunch of other kind of similar tools, basically that you can just install into your either org or your repo, and it allows you, or it automatically will send PRs and create issues depending on the status of a dependency update when it's time. So here you can see that there's a PR opened on my good first issue repo. It's just updating a dependency, right? Boxin is a dependency from Syndrasaurus that creates a box in the CLI. That's all it is. The output is the module is a very non-breaking module. It's relatively easy to update. So I can just click merge on this. It does run my tests, and it also gives me, so it's a PR, so it'll run my tests. If I scroll down a bit, it also gives me information about the changelog and all the commits that have happened since the previous release, which is a really, really useful tool to see if I can trust this this change. And it will even give me the git commit itself, like the link to the commit, in addition to the commit message. So I can just, I still haven't, I can just go click merge on this PR, publish a new version, and be good. Here's an example of a breaking change that shouldn't happen. So octokit/rest, which is the GitHub API, the REST API or REST module, did an in-range breaking change. So this is my semver range inside of my package JSON. It is a breaking change happened, even though it bumped within that range. I'm not doing what I suggest other people do in this module and pinning to the patch versions. I'm instead letting minors update. So this kind of thing can happen when you let minors update. And I wouldn't have known this would have happened if I hadn't had Greenkeeper. So this is a really, really good way to understand both your modules and your dependencies all the way down, and get a bit of insight and automate this process, right? We shouldn't, as humans, be updating this. We should be given the work, and we should be validating it, but we should not be doing this work ourselves. Okay, so that's Greenkeeper. There's another really interesting one to me. It's called Dependabot. So recently, Dependabot is more of a polyglot solution. Greenkeeper is very much focused on JavaScript. Dependabot is definitely a polyglot solution. So if you're using Java and Ruby and Python or any kind of mixture, it just works. It's really nice. Recently, they were acquired by GitHub at GitHub Satellite. So this feature is actually currently migrating to be a part of the GitHub platform. And so they are using Dependabot as a way to automatically send you security notices and security warnings when there are issues in your dependency tree, regardless of what language, directly inside of GitHub. So you can actually see here, none of these tabs on GitHub are selected because it's actually in the more dropdown. But basically what this is this is the security alerts page. Right now, my Nanoprobe repo has no alerts. However, this is I've obscured the actual repo that this is because I don't want any of you attacking it. This is a vulnerability in handlebars, and it actually tells me, the vulnerability, how to remediate, and also the details in terms of the CVE. Sorry if that's a little too low in the back. But yeah, so it gives me all the information I need to be able to determine this, and also this green button will automatically create a PR that will allow this. The thing I like about this approach is it actually allows me to be a gatekeeper and not have this information be public before I'm ready for it to be. So I can just click create PR. If I know this will not break, I can click create PR. It will run my tests. I can merge it if they pass, and we're good. But in the case of Greenkeeper, it's not specifically focused on security, and so it will just always PR your updates. And so there's trade-offs there, and there's benefits, and I prefer the Greenkeeper approach just because it reduces the maintainer burden. But yeah, these are both really good approaches, and this one's built into GitHub at this point. So Greenkeeper and Dependabot are both awesome. Both help you address vulnerabilities, one by automatically updating as fast as humanly possible. Dependabot is integrated into GitHub in that way. They're also integrating automated updates, which Dependabot as a bot does. But there's also a bunch of other tools, right? So these are the icons for the logos for the other ones that I've found. This is Sonatype, Depth Shield, MyGet, which is more focused on .NET, Renovate, and DepFoo. All of these work. It doesn't matter which one you choose. Just choose one that helps you kind of keep ahead of vulnerabilities and vulnerability disclosures, so you can kind of not have to care as much. So let's talk about another tool that you're already using, right? You already have this. Let me rephrase. How many of you have Node installed? Okay, most of you are liars, because I know you have Node installed somewhere. So this is a tool you already have installed because you have NPM. Npm Audit is a relatively good tool. I really like it, regardless of any issues people have with NPM or the NPM CLI itself. Npm Audit is actually a really useful tool because it goes and reaches out to NPM's database of vulnerabilities by default. And this is a really good way to just kind of get a free check in your CI. So you can see that, you can roughly see that I just ran NPM Audit. There's 0 vulnerabilities, and the exit code, which you can find with exit $? Is 0. No vulnerabilities, it exits well. If there are vulnerabilities, so I'm testing a repo called Goof. This is a repo that's intentionally built for vulnerabilities. It has many vulnerabilities in it very intentionally. You can see here that there are 62 vulnerabilities, 19 of them were high. I have a lot of information that I can use here. It exits with a 1. Very, 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 very simple check to make sure you have no vulnerabilities in production, or at least going to production, right? So this is something I like to suggest people use as a CI step. Just, it's a single line. You can even do JSON output if you want, but this is a pretty good way to just gate and have a check of, do I have vulnerabilities? And for some orgs, this matters more. For some orgs, this matters less, but it's a nice thing to have regardless. Okay, so the steps you can take: automate your dependency updates. Please, please, please. It might seem like it's a burden at first. In reality, at least in my experience so far, it has really helped myself and others that I've talked to who have done this and instrumented this to be able to address problems much more rapidly, and it gets their team moving much faster, which does have fatigue, but it also it's faster at the cost of reviewing a PR rather than doing an update, running your tests, pushing a PR, updating that PR, having others review it, and then accepting it. And then also use NPM Audit in your CI. It's a relatively low barrier, and hopefully that's a helpful one. Quick tip that you can take away from today. Okay, so we've covered code coverage. Again, not just code coverage, vulnerability code coverage. Now let's get into runtime. So this is the one I'm really excited about. Yeah, so again, we're going to talk about runtime coverage. In this one, there's not really a simple answer. I've not seen any tools that are available for for widespread consumption. I've seen a few tools that have done this, done a kind of checking that allow you to see, am I running a vulnerable version of Node in production? And those tools are built into other products that you have to pay a massive amount of money for. I've not seen anyone actually go and build this as a tool that anyone can go use, at least not yet. So when we're talking about runtime security, what do we really need to think about? We need to know if there are existing deployments that are insecure, right? So I have hundreds of apps up in the cloud. Are any of those running an insecure runtime? That one's hard. That one should really be on your cloud. Regardless of what cloud you're using, they should be doing this and surfacing this information to you. As far as I know, most or all clouds do this to some extent. If they don't, go ask them to. I know every single cloud that I've talked to, at least, including the one I work at, really acts on user feedback, and being able to go and ask them something for such a feature is really valuable to them. And so if the apps you're using or the services you're using don't already do this in the cloud, please go ask your cloud to do this. It helps not only you, but everyone else. So yeah, that's a hard one that the clouds can really help with. The next one is, are my new deployments safe? So when I'm hitting deploy to production on something I already deployed to staging, already tested, is this going to be safe? Am I deploying with something that is a known vulnerability already? And this can generally be done through CI/CD. I'd be concerned if people were deploying to production without running their tests in a usable environment already that's similar to their production environment. Please come talk to me if you are, because we need to have a heart-to-heart. And additionally, can I automate this with PRs, right? Can I automate this inside of my my repos where I'm doing my work? So yeah. Addressing, are my existing deployments secure? Please talk to your cloud. Are my new deployments secure? Like I said, I've seen a few solutions. Well, I've seen a few solutions in general, but not specifically to this one. I've actually created a few solutions and worked with a few solutions. One of my old teammates created a Slack bot that just automatically posted every time there was a new version of Node into our Slack team, right? There's also a Docker publish feed, but that gets noisy because you're not actually listening to Docker images that are about security vulnerabilities. You're just listening to every publish, which we do relatively often. And also, I previously built something on the GitHub releases feature. Turns out Node doesn't very actively follow that feature in a way you'd expect. We publish tags first and then eventually get around to doing the release, just because of how many steps we have to do to make a release. So that's not really a reliable way to do to listen to Node releases at this point. And then there's an additional thing that we'll get into in a second. But this is something that I've felt for a long time. I wanted to know, like, what is the minimum version of Node that I can and should be deploying? How do I address that? How do I use that data? How do I use that information? And so I've been working on a tool recently that hopefully kind of helps address some of this. It's called Nanoprobe. And so what Nanoprobe does is it's a CLI. It helps you kind of better understand your Node apps or your Node deployments, right? The version of Node that you're actually running. So one specific command called the Nanoprobe safe is the thing I'm really excited about in this space. There's a few other uses of it, but this is the specific command that I'm really excited about. So what is Nanoprobe safe? So Nanoprobe safe is a CLI. It's a single command. It will tell you if the version of Node you're running is safe. So specifically, if you don't pass an argument, it will just tell you if the current version of Node that's running on your system has any known vulnerabilities. Here you can see I'm running 12.2. The newest node is 12.5. I created this image like 3 weeks ago, so we release often, at least for current. So yeah, this version is safe, right? Node 10.2.0 is not safe. There have been 2 security updates since that, and they both are actually relatively important security updates. Often Node security updates aren't even in Node, they're actually in OpenSSL, which is super scary if it's a bad one. So, this is a really good way to kind of consume this information and get it directly either in development or in a CI state. But yeah. So these also have JSON arguments, so you can actually just output this as JSON if you want to put it output it to a file or log this specifically in your CI, you can. And additionally, each of these commands actually exits. So there's Nanoprobe safe CI, which will not output anything. It will just output the correct exit code. Additionally, each of these commands actually exits with the proper exit code, regardless of if it's CI or not. So it's a little small, sorry, but the safe ones exit with 0, and the unsafe ones exit with 1, regardless of what command you're actually using. This is just a way to make sure that you can get the information you need to act on as soon as possible. Because if you're using an unsafe version of Node in production, that can be really, really bad, and that can be really bad. So please, please, please make sure, regardless of whether or not you're using this, please make sure you're using a safe version. So this entire thing is built on serverless CLI. I'm not running a function in your CLI, but this is backed by serverless. So I actually have an API up that surfaces all the information I need for this. I'm going to be open source. Well, it's already open source. I'm going to be making that API much more public soon. But basically, I'm trying to make sure that this information is readily available, however possible. An API, a simple API, is a very good way to do that. Additionally, if you don't want to use an API I have, or anything someone else has built, you can go build something off of this data yourself. Node.js has a a URL, a JSON file, that has the release metadata for every single release we've ever done, except for IOJS, because those aren't Node releases. And that metadata is actually really useful, and it has a single property in there called safe. That is a Boolean. If it is true, that version was a security release. Very, very simple way to address this. If you want to go build your own tooling, please do. And please open source that as well so others can use it. Cool. So you can use Nanoprobe in your CI/CD build steps. You can build your own tooling with the dist/index.json file at the Node.js website. And also ask your cloud providers to surface this data to you. That's super important and something that most, if they're not doing already, should be doing. Cool. So we've addressed our needed coverage. That's all of them. Let's do a quick recap. Cache your modules. Please, God, do this. Please. This is a super important thing. It will save your business literally billions of dollars. Or, well, if you're a massive company, regardless, it will save a massive amount of money for your company. And it can save up to billions. Yeah. Have an incident response plan. Please, 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 regardless of whether or not it's for modules and for outages and human attacks, this is a very, very important thing. Automate your dependency updates. This is a really good way to kind of be in the JavaScript ecosystem flow and address, address issues before they happen. And again, know your runtime. Dankeschön.